is practice exam problems 3 over Wronskian's linear dependency and one other thing. Okay, this is practice exam 3 problems, and I will just go ahead and start. So the 3.1 is just over finding the Wronskian of functions. So if you remember Wronskians, see the Wronskian of 1 plus x, comma x squared. It's just a matrices, 1 plus x, x squared, and you take the derivatives going down. So the derivative of 1 plus x is 1, second derivative is 0, 1, 0 again. We get 2x and then 2, so we're going to now evaluate this. Well, I guess not really evaluate it, just finish the matrices. So I have 1 plus x and then times these terms. So 2 minus 0. Okay, and then minus, because keep in mind you have to alternate your signs. Okay, so minus our x term. And then that's going to be these terms. Okay, so you have 2 again minus 0. And now our last term plus x squared, which is going to be these guys here, but that just goes to 0. Okay, so we have 1 plus x times 2 minus x times 2. So we have 2 plus 2x minus 2x equals 2. So your Wronskian equals 2, and when your Wronskian equals a constant, that means that it is linearly independent on all x. So that's the interval, is all numbers. Okay, so let me get rid of this and we can start on the next problem. That's good enough. Okay, 3.2. We are solving this homogeneous second order using reduction of order. Okay, so we have x squared y double prime minus 7xy prime plus 16 y equals 0. We're going to put it into standard form first, so we get y double prime minus 7 over xy plus 16 over x squared y equals 0. Okay, so if you remember the formula we use for reduction of order is y equals 2 times, y sub 2 equals y1 times the integral of e to the negative integral of p of x divided by y1 squared. Ex. Okay, so we're going to plug our values into that formula. So we have y2 is equal to our y1, which we're told is x to the 4th, times the integral of e raised negative, and our p of x is that's negative 7 over x, so it's positive 7 over x dx, and then over our y1 squared, which is going to give us x to the 8th dx. Okay, simplifying this, you get x to the 4th times the integral of e to your 7 over x dx, x to the 8th, and that's going to equal x to the 4th e to the natural log of x to the 7 over x to the 8 your natural log and your e go away, so you get your y2 equals x to the 4th times x to the 7th over x to the 8th dx. So this is going to go to x to the 4th times your natural log of x. Okay, and that is your y2, meaning that your complete answer is c1 times your y1, which was x to the 4th, plus c2 times your y2, which we just determined, the x to the 4th ln of x. And that is the solution to that problem. Okay, so let's start on 3.1b. Again, it is a Wronskian. I'm just gonna write f1, f2, f3, Wronskian of those functions. X squared, 3x plus 5x squared. Okay, again, we're just gonna take the derivatives going down. X goes to 1 and then to 0, 2x, 2, 3 plus 10x, then 10. Okay, so we're going to do the same thing. Go ahead and put our sign convention up there. So for our x term, we have this happening. So we have 20x minus our 6 plus 20x. Okay. Okay, and then for our x squared term here, again, we have a minus from up here already. So we're going to do these guys. Okay, so we have our x squared, and then our 1 times 10 gives us 10, and the next term is 0. And now we have our 3x plus 5x squared. Again, it's positive, sign convention-wise. And we have our little fish here. Okay, which is just going to give us 2 minus 0. Oop, that's not what I wanted to do. There we go. Okay, so now we're just going to condense this all down and see what we get. So we have 20 x squared minus 6x plus 20 x squared minus 10x squared plus 3, well, plus 6x plus 10x squared. Okay, and if you can see, all of these terms cancel out. Okay, so that goes to 0, and when it is 0, that means that your Wronskian is dependent. So yeah, that's all you have to write, is that when your Wronskian equals 0, the functions are dependent on all x, or whatever. All x, yeah. Okay. So now for the last problem. We have x squared y double prime plus 2xy prime minus 6y equals 0. Putting it in standard form, this gives us y prime plus 2 over xy prime minus 6y divided by x squared equals 0. Again, we're going to use that same formula, given that our y1 equals x squared. Okay, so we know that y2 is going to equal x squared times e to the negative integral of 2x dx all divided by x to the fourth, because it's y1 squared down here. All the x, that goes to x squared times the integral of e to the ln x to the negative 2 divided by x to the fourth dx, which then goes to x squared times the integral of 1 over x to the 6th dx, which gives us our y2 equals, I'm sorry, this is x squared. Our y2 equals negative 1/5 x to the negative 3. This 1/5 doesn't matter because of the principle of superposition, so we can rewrite our answer as c1 x squared plus c2 x to the negative 3. And that is the solution to this problem, and that concludes practice tests 3, A and B, and let me know if you have any questions on these.